Hi again, my name is Gene and I'm a new mentor for High School Robotics team FRC 714. This video series is about how easy it is to program FRC robots in Python, the language of many modern apps and most AI products. Previously, we have put together a simple command for a robot to drive up and pick up a game piece from the floor. Today we will write a slightly more advanced command which uses timers. It will spin the shooter to the desired speed, then feed the game piece into the shooter and shoot it out. When the button is pushed and the command starts, the shooter will start spinning and accelerating, but only when it reaches the desired speed. The intake roller will feed the game piece into the shooter and it will shoot out. All while the button stays pressed. Most importantly, this command also has a timeout. The command stops after 5 seconds no matter what, even if the shot was not completed. This kind of stuff is pretty useful for autonomous commands, for example. Now a question to you. How many subsystems are needed to pull off something like this? That's right, we need 2 subsystems, a shooter and an intake to feed the game piece into the shooter. So let's get to it. In the description of this video there is a link to our GitHub webpage with all sorts of code snippet examples. This code will work on a swerve robot or on a tank robot, it will work anyway. If you scroll to the bottom of this page, there is an example of a shoot command, and this is what we're going to do today. I'm going to click on this. There are 2 prerequisites. It is important that you already have a shooter subsystem in your code, and here is a link to how to add it. There is a video also previously in this channel. And if your robot does not have an intake subsystem yet, here is also a link to how to add the intake subsystem. What we're going to assume is we're going to go to the robot code in the state in which it was after we added the pickup command from the previous video. So what it means is there is a commands folder in here in our robot project which has a pickup command code. And let's see what we need to do to add the shooter command. First we need to create a new file, commands/root.py, and inside of that file there we need to put the code for the root game piece command. Here I'm going to copy this code. I'm going to create a new file inside of the commands folder, root.py, and I will put the code into it. Second, it is important to bind this command to some button. And here it's going to be a left bumper button. So we have to go to robotcontainer.py. Where is it? Here, I found it. We need to find the function called configure button bindings, where we bind all the buttons to commands. I think I found it here. Here's the function. And we need to put some code into it. This code below must be added somewhere to the function. I will just add it to the beginning of the function. Let's read. What does this do? We create a shoot command, which is a command that takes the intake and the shooter, and the shooter RPM for the shot is specified at 1500. What is missing here is a timeout. We want to end this command within 5 seconds, even if it doesn't finish on its own. So what I can do is I can simply add dot with timeout and specify how many seconds I'm going to give this command to run. Second, we create a left bumper button, which is the left button, and we bind this command to run while left button is pressed. While means if I unpress the left button, the command will stop immediately. Let's test it in simulation, shall we? I switch to sim, and I'm going to run the sim configuration. The simulated robot graphical interface comes up. I take my Xbox controller joystick, I make it joystick number 0, and let's see what happens in the output of the program when I switch the robot to teleoperated mode. And I hit the left bumper button. Huh? It's doing something. It's doing something to the intake, it's setting the velocity goal on the shooter, and it's feeding the game piece forward into the shooter. And then they both stop. Okay, not too bad for simulation. Let's do it again. Push the left button, and the whole thing repeats. Great, tested in simulation. It is time to deploy this code to the robot. So I'm going to connect to the robot Wi-Fi here, refresh the list of networks. Do we see our robot network in here now? Here, connected. Switch to the deploy configuration and run. Deploy was successful. Let's see if it works. When the button is pushed and the command starts, the shooter will start spinning and accelerating, but only when it reaches the desired speed, the intake roller will feed the game piece into the shooter and it will shoot out. All while the button stays pressed. Okay, so we know it works, but it's probably important to understand what this command actually does. Let's go and read the code. I'm going to commands shoot.py. So the shoot game piece command, to initialize, to create a command, we must have an intake and a shooter and the speed at which we want the shooter to rotate before the game piece is fed into it. When the command starts, which is the initialize function, what we do is we say, hey, we have never fed a game piece into the shooter by setting feed time equals 0. We stop the intake. We call the intake.stop function. and we give the shooter a velocity goal of, for example, 1500 RPM, or whatever was specified at the time the command was created. And the shooter will start accelerating in order to meet the velocity goal that we have given it. Finally, while the command is running, what is happening? The execute function will be called many times while the command is running. If feed time was 0, which means the game piece was never fed into the shooter yet, we're going to put important numbers on the smart dartboard. The actual RPM of the shooter and the target RPM that the shooter wanted to have, so that later we can see how well the target was reached at the time when the game piece was fed. Here is what happens in the smart dashboard. The target RPM was 1500, while the actual RPM was, well, less than this at the time of the firing. I'm sorry, this is the target RPM, 1500, while the actual RPM was smaller. Finally, if the feed time was 0 and the shooter velocity is greater than 90% of what the goal was, then we command the intake to feed the game piece forward into the shooter. And we make a note what time it was at the time we started feeding the game piece into the shooter. How does the command know when it's finished? Well, it's actually easier to say when you're not finished. If, for example, feed time was 0, meaning that you never fed the game piece into the shooter, then return false. No, the command is not finished. We never even fed the game piece into the shooter. Second, if it's not the case, which is if we actually fed the game piece into the shooter, what time is it now? Is it before the feed time plus half a second? And if it hasn't been at least a half a second since the feed time, we say no, false, the command is not finished yet. Otherwise, we have no reason to think that the command is not finished. Otherwise, if we're here, then, of course, the game piece was fed into the shooter, and the time right now is more than half a second after the feed time. So we can comfortably say we are done. Return true. The command is finished. So the last thing we need to say in the command is what must happen when the command must end, either because it timed out or because it actually completed. This is the end function. The end function here is very simple. We must stop the shooter and we must stop the intake if they were spinning. And that's all there is to it. Today we took a look at another command, which was slightly more complex than the previous one. But if you look at it more carefully, it still had the same 4 functions inside. What to do when the command starts, what to do while the command is running, how to decide when the command is finished, and what to do at the end when the command is finished. We have bound this command to the left bumper button, and it worked. Thank you for staying with me, and this is all I had for today. Thank you for watching.